This is the study island topic unit circle that I'll be helping you with. First thing you should do is open the lesson tab next to your practice problems. This will be a handy reference and you'll be able to use it for a lot of these problems. So please open up the lesson tab. Next, I'm going to go over a couple of things before we actually get into the problems to make sure that you understand what a radian is and things like that. What exactly is all of this stuff that looks really confusing? It'll be pretty simple to break down. So let's just get started on that and then we'll get into the problems. First things first, what is a radian? Here's your definition right here. It's the measure of an angle which, when drawn as a central angle, subtends an arc whose length equals the length of the radius of the circle. What is all that? Let's break it down. It's the measure of an angle. Normally we measure angles with degrees. An entire circle is 360 degrees. You know what a 90-degree angle is, et cetera, et cetera. We measure angle with degrees normally. Radians are another way to measure angles besides degrees. It's kind of like you might measure weight in kilograms or you might measure weight in pounds or something like that. You have two different ways to measure weight. Well, we have multiple ways to measure angles. The most popular is degrees, but we also use radians. Why do we have another way to measure angles rather than just degrees? Why do we use radians? Because radians use the length of an arc on the circumference of a circle that is equal to the radius. So here's an animation that will explain that in a little bit more simple to easy understand visual process. Let's say you're going to create a circle. So there we go. That length right there is the radius. So that red line is a radius. It's the length between the center of the circle and all the points on the circle. That is the definition of a circle. A circle is a collection of all the points that are one distance away from a central point called the center, and that distance that they are all away from is called the radius. So you've got that red line, which is the radius. What this animation is about to show you is it's going to take that distance and mark it on the circumference of the circle to create what we call an arc. An arc is a part of the circumference that's equal to the radius of the circle. So here we take that red line and let's mark it on the circumference of the circle. So there you go. So now you have a length of an arc that's equal to the length of the radius of the circle. So now let's create a central angle. A central angle is an angle that's in the center of the circle there that goes and intersects 2 points on the circumference. And that central angle is 1 radian. The measure of that angle, rather than putting it in degrees, we say that the measure of that angle is 1 radian. It's the size that that angle has to be so that the arc that it intersects there is exactly the same size as a radius of the circle. So there's a radian. So now we can convert that to degrees, but it's an irrational number. It's not very nice, so we're not going to right now. It's just going to be called 1 radian for the moment. So what happens if we make another one of those next to it? Well, if you have 1 radian and then you create another angle the exact same size, you have 2 radians. And then 3. Now what happens next might confuse you for a moment, but just stay with me. Instead of going to 4 radians, 5 radians, 6 radians, we're going to finish off the half of the circle. You can see that we've gone all the way around to here and not quite all the way to make a semicircle, a half a circle. But we're going to finish that right now, and it's going to be pi radians. And then, of course, if half a circle is pi radians, you go all the way around the circle. You'll have another pi radians, which is 2 pi radians. So now let's stop and think about what we do know about the angles of a circle. A circle is 360 degrees. And according to this animation, a full circle is 2 pi radians. So what you've got is that 2 pi radians, 2 pi radians has got to be equal to 360 degrees. Now, where did 2 pi radians come from? Why is that? Why is it true? Why is it that half a circle is pi radians? Well, it's pretty simple if you just remember your circumference of a circle and what a circumference is. First of all, any circle, the circumference of the circle divided by the diameter of the circle is equal to pi. That's where pi comes from. Pi is always the circumference of a circle divided by its diameter. If the circumference of the circle divided by the diameter is pi, then you could say that the circumference of the circle is the diameter times pi. Well, we also know that the diameter is the same as 2 times the radius. If you have 1 radius and another back to back, that's 2 radii. So I can say that the circumference is equal to 2 times a radius times pi. Well, if the whole circle is the circumference of the circle, I should say, if the length of the circumference of a circle is 2 times the radius times pi, and I have an arc that is equal to the length of a radius, and that arc creates a central angle that's called a radian, then I can figure out how many radians are in the circle by figuring out how many times I can go around the circle with a length of an arc that's equal to the size of the radius. Well, the entire circumference is 2 times the radius times pi. If I want to know how many radii fit into that, I would just divide. So I have 2 times the radius times pi divided by the length of a radius. And what happens there, our radii, they cancel out. And so you get 2 times pi. So you have 2 pi. So that is how many lengths an arc how many lengths of an arc that are equal to the size of a radius can fit into the circumference of a circle. You can fit 2 pi worth of them. So that's where it came from. And of course, if a full circle is 2 pi, then half a circle is 1 pi. So that's where all these pi, radians, and all that stuff comes from. So now we can do some stuff with that. Let's take a circle. Let's say we've got a circle here. I'll draw one real quick. Okay, here's a circle. Okay, there's a circle, and I've got my center right there. Make sure you can actually see the circle. So there's a circle. Now, let's say that we have on this circle a 90-degree angle right at the center. I didn't do an actual construction of a 90-degree angle. Let's just assume that I did it right. So if that's 90-degree angles, if that's a 90-degree angle, imagine that this was a coordinate plane where the center point right here was 0, 0. So imagine we got a big coordinate plane. That would make our x-axis this entire thing, and our y-axis this entire thing. And so we've got 0, 0 right there. Now I want you to imagine that this is the point 1, 0 on the coordinate plane. Well, that means that this entire distance right here would be 1. So all of these distances are 1. It's a circle. So that means that this has to be over here, 0, negative 1. Up here, this is 0, positive 1. And over here we have negative 1, 0. So we've got a circle, we've got the middle of the coordinate plane, we've got a right angle, obviously, because the intersection of the x-axis and the y-axis are going to make a right angle. So if you've got this circle here, and you know that the length or the size of an angle that creates an arc that's equal to the size of a radius is equal to 1 radian, and the entire semicircle is now pi radians, well, we can do some conversions here. Imagine you've got pi radians all the way across. So it's the length of this. Well, isn't that 180 degrees? Yeah. So if you have 2 pi radians is 360 degrees, 1 pi radians is obviously 180 degrees. And what's going to be 90 degrees? Well, we can just keep doing this. What's 180 divided by 2? That'd be pi over 2. So let's go ahead and start listing these out. If you've got 2 pi radians, that's 360 degrees. Divide both sides by 2. That gives you pi radians, which is equal to 180 degrees. What if you divide that by 2? That would have pi over 2 radians equals 90 degrees. Well, what if you took pi and divided it by 6? Pi divided by 6 radians would be the same as 180 divided by 6, which is 30 degrees. So you can find out all sorts of measurements like this. You can convert your radians to numbers of degrees. So for example, let's say you wanted 45 degrees. If I want to know what 45 degrees is in radians, all I have to do is figure out what portion of 45 what portion of, I should say, 180 is, that 45 is out of 180, and that's going to be equal to how many radians that pi is, how many radians out of pi we have. So that's going to be x out of pi. So 45 out of 180 goes in 4 times. 45 times 2 is 90, times 2 again is 180. So 45 out of 180 is 1/4. So 1/4 equals x over pi, and then you have pi times that. So if you have times pi on both sides, you get pi over 4. So pi times 1 is pi. 1 times 4 is 4. That makes pi over 4 radians equal to 45 degrees. So this continues on, and that's what you're looking at when you look at the unit circle over here. Take a look at these. See where it says t equals pi over 2? That's the 90-degree angle that would be created if you had one line right here, and then went straight up. That's a 90-degree angle, so it's pi over 2. Well, pi over 6, that's a 30-degree angle. So if that was a 30-degree angle, you have pi over 6. Here's a 45-degree angle, pi over 4. What's this one, pi over 3? Well, we could figure that out by seeing what ratio pi over 3 is. So we've got pi over 3, or 3 over pi if you wish, whichever one you want, equals the angle out of 180. So you've got pi over 3 out of pi equal to some number out of 180. And so pi over 3 divided by pi over 1 is the same as pi over 3 times 1 over pi, which cancels out. So that's equal to x over 180. So now you have 1/3 equals x over 180, and then you multiply by 180 on both sides. And we're just solving proportions here. This is basic 7th grade math at this point. 180 times 1 divided by 3 is 60. So you have 60 equals x. So if you have pi divided by 3, that's 60 degrees, because that would be pi over 3 out of pi is 1/3 of pi, and 1/3 of 180 is 60. So this is a 60-degree angle that would be created going from right there to right there. It says pi divided by 3. And it keeps going like that. If you have another 30-degree angle, well, if a 30-degree angle is pi divided by 6, and right here you have pi divided by 2, what is pi divided by 2 plus another 30-degree angle, which is pi divided by 6? So let's do the math. If you have pi divided by 2 plus pi divided by 6, what is that? Those are the two angles that are created if I go from this part of my circle right here to the central angle, and they create an angle up that way. It's obviously my 90 degrees plus another section right here, right? Well, it says that it's 2 pi over 3, and this is another 30 degrees, just like this 30 degrees was. So it's my pi over 2 plus pi over 6. If I want to make that common denominators, I have to multiply both sides by 3, so it's 3 pi over 6 plus 1 pi over 6, which equals 4 pi over 6, and 4 and 6 simplify by a factor of 2, so it becomes 2 pi over 3, and sure enough, that's what it says right there, 2 pi over 3. So all you have to remember here is that every 30-degree increment is pi over 6, every 45-degree increment is pi over 4, every 90-degree increment is pi over 2, and then you keep going around the circle, and you'll keep getting these measurements right here. So 5/6 pi is going to be 30, 30, 30. It's 5/6 of it right there. That's where all those measurements come from. So what are all these other things? What are these ordered pairs, these crazy looking ordered pairs? Well, let's go back to our unit circle for a moment. If this is 1, 0, and I create an arc that goes 30 degrees, and I'm going to measure this just roughly. I'm not going to get an exact measurement for my on my protractor right here. But let's just say I have a 30-degree angle. Be right about there. Let's say. Okay, so if I make a 30-degree angle right there, that 30-degree angle is equal to what we've already discussed in radians, pi over 6 radians. So 30 degrees is equal to pi over 6 radians. But what are the xy coordinates of that point come out to be? What are the xy coordinates? We know the xy coordinate here is 1, 0. We know that that's 0, 1. What are the coordinates of that going to be? Well, let's make a right triangle out of this. If I make a vertical line from this point and go straight down, I've now created a 30, 60, 90 degree triangle. 30, 60, 90 degrees. If that's 90 degrees and that's 30 degrees, that has to be 60 degrees. And hopefully you already know that a 30, 60, 90 degree triangle has very specific ratios that the sides have to be. The shorter leg, we call that 1. The hypotenuse of the triangle is whatever the shorter leg is times 2. And the longer leg is whatever the shorter leg is times the square root of 3. So how does this help us with our xy? Well, if we keep these ratios in mind, then we know what the x and y coordinates have to be. You take a look over here, you have the square root of 3 over 2 and 1/2. Where do those come out to be? Well, if I have a length here, and a length here, and a length here, and this is 1, 0, and these are the ratios that I'm using, well, this radius has to be equal to 1, because this ratio right here is going to be, this length right here is a radius, which means it's the exact same as that length right there. Those two lengths are both radii, so they have to be the same. So if the ratios are 1 to 2 to root 3, and this length right here, the hypotenuse, is equal to 1 unit, then I can change these. The radius is worth 1. That's double whatever the short leg is, which makes this 1/2. And this is whatever this is times the square root of 3. So it's going to be the square root of 3 divided by 2. So those are the measurements in the unit circle of these three sides. Our radius is 1 because it's a unit circle. And in a 30, 60, 90 degree triangle, the short side is always going to be half of the hypotenuse. And the longer leg is going to be the shorter leg times the square root of 3. Half of square root of 3 is the same as square root of 3 divided by 2. Well, if I know this length and I know that length, I now know my x and y coordinates. And that's what it says right here. Square root of 3 over 2, square root of 3 over 2, and then 1/2. 1/2. So those are my xy coordinates. Now, similarly, if I were going to do the exact same thing with a 45 degree triangle, a 45 degree triangle, and I'm just going to draw this separately because it's getting a little messy here. A 45 degree triangle has its own special ratios. If you have a 45, 45, 90 degree triangle, so let's just say we've got okay. So let's say we've got a triangle right here, and this is 90 degrees, and this is 45 and 45. Well, the ratio of these sides is always 1 to 1 to the square root of 2. Well, if you think about it in terms of our unit circle, let's say that this is the center right here. I'll draw another quick circle. Here's our new unit circle, let's say. And again, in our unit circle, we have a center. And I'll say we have a y, an x-axis. Okay, so we have our unit circle again. Remember that this is 1, 0, and this is 0, 1, etc., etc. If I have a 45 degree angle right here, I'm not measuring exactly 45. I won't measure exactly. I'll measure more precisely, I should say. Not exactly. So if I've got a 45 degree angle, okay, so now what are the coordinates of this point in xy if this is 45 degrees? Well, we're going to do like we did before. We're going to create a right angle by drawing a line that goes straight down to the x-axis. That creates a 90 degree angle. And that means my triangle has to be 45, 45, and 90, because all the angles in the triangle have to add up to 180, obviously. So 45, 45, 90. So 45 degrees, and 90 degrees. So again, I have this type of triangle where it's 1 to 1 to root 2. The hypotenuse is the thing that's the square root of 2. So if this is the square root of 2, but it's the same as the radius of the circle, remember its length is 1. So how do I get from the hypotenuse to one of these other numbers? I divide by the square root of 2. The square root of 2 divided by the square root of 2 gets me 1. So I have to do 1 divided by the square root of 2. So this length right here is going to be 1 divided by the square root of 2. Now I'm not allowed to leave a fraction with a square root in the denominator like that. So what I do is I say, well, I'm going to multiply this by 1 in the form of the square root of 2 divided by the square root of 2. The square root of 2 over square root of 2 is just 1. Anything divided by itself is 1. So I'm not actually changing my fraction. But what I get when I do that is 1 times the square root of 2, which is the square root of 2, and the square root of 2 times the square root of 2, which is just 2. So the square root of 2 over 2 is the same thing as 1 divided by the square root of 2. Those are the exact same. But I'm going to use this one because it doesn't have what we call radical in the denominator. It doesn't have a square root symbol in the denominator. This length is going to be the exact same because the ratio in a 45, 45, 90 degree triangle is that the two legs are the same size. So this is also going to be the square root of 2 over 2. So the square root of 2 over 2, and there we go. And of course, that's what it says right here on the unit circle, square root of 2 and square root of 2. And then this one is the exact same thing as the 30, 60, 90, but just flip-flopped because if you have a 30, 60, 90, one of the angles is 30 and the other is 60. So you're just reversing in our 30, 60, 90 degree triangle the lengths that we had earlier. So you've got 3 sets of coordinates there in between 1, 0 and 0, 1. You have the square root of 3 over 2 and 1/2. You have the square root of 2 over 2 and square root of 2 over 2. And then you have 1/2 square root of 3 over 2. All the rest of these are the exact same numbers, but with positives and negatives that make the coordinates appropriate for their quadrant. If you're in the left quadrant, you've got, or left quadrant, quadrant 2, I should say, that's going to have a negative x value and a positive y value. And you can see the symmetry. Look at the first one right here. Root 3 over 2, 1/2, negative root 3 over 2 and 1/2. And then the next one up in both sides, negative root 2 over 2 and root 2 over 2, positive root 2 over 2 and root 2 over 2. And then closest at the top there, negative 1/2 root 3 over 2, positive 1/2 root 3 over 2. So there's symmetry there, and it continues down this way. It's the exact same numbers, but with different positives or negatives to make sure that the quadrant that it's in is appropriate. So knowing all of that, hopefully we can start doing some of these problems now. Let's get started. Okay. Number 1, find the length of the arc intercepted on the circle by the following central angle. What if theta, and remember theta is the measure of the central angle in radians, is pi over 2? Well, if we go to our unit circle here, where's pi over 2? It's right here, 0, 1, pi over 2. So when we're looking at this, find the length of the arc intercepted on the unit circle by the following central angle. What else is going to be the same there? Well, you've got pi over 2. It's already there. It's just pi over 2 and pi over 2. You don't have to do any conversions on that thinking. It literally just says the answer right there. 3 pi over 2 would not be, if you looked at 3 pi over 2, where's 3 pi over 2? That's at the bottom down here. If you had negative pi over 2, that would just be going the opposite direction. So that'd be down there also. And then pi would be 1 halfway around all the way. So that's not going to be the same either. Keep moving. Okay, what if theta is 41 pi over 6? Find the corresponding point on the unit circle for the radian measure given below. What in the world is 41 pi over 6? Well, let's think about this. If we go around once, that's 1 pi. If we go around twice, that's 2 pi. What if I kept going around 3 pi, 4 pi, 5 pi, 6 pi? You can keep going around in sections. So what we're going to do with this one for 41 pi over 6, let's figure out exactly how many times we go around that circle. Let's figure out how many sets of 2 pi we have. Let's figure out what 41 divided by 6 is. So if we have 41 divided by 6, 41 pi divided by 6. 6 goes into 41 6 times with 5 left over. So that's 6 5/6 pi. 41 divided by 6 is 6 5/6. So that means I'm going around the circle 3 full times because every 2 pi is 1 full rotation. So 2 pi is all the way around, another 2 pi is all the way around, another 2 pi is all the way around. So I'm going around 3 full times, and then 5/6 pi more radians. So this is just going to be, after 2 pi, back to where I started, back to where I started, back to where I started. Then I'm going 5/6 pi around one more time. If I go back to my unit circle, where is 5/6 pi? Right here, 5 pi over 6, which is negative root 3 over 2 and 1/2. So we just find that xy coordinate, negative root 3 over 2 and 1/2. So again, if it's more than just a simple measurement that you see already on your unit circle diagram, you're going to have to convert whatever it is into how many times you're going around the circle. And every 2 pi is one full rotation. So you can just kind of start over after that. Let's do another one. What if we have 3 pi over 4? Well, if I'm looking for that on my thing, 3 pi over 4, which is 3 times pi divided by 4. Well, I don't see that anywhere. Do you see that anywhere? 3 pi over 4? Oh, there it is right there. Negative root 2 over 2 and root 2 over 2. So just 3 pi over 4. It's right there. You don't have to do any extra information on that. So again, that's a negative and a positive. So there's our answer right there. Find the length of the arc intercepted on the unit circle by the following central angle. We have 5 pi over 3. 5 pi over 3. So if you've got 5 pi over 3 somewhere, you'll be able to find it. And there it is, 5 pi over 3. It's just 5 pi over 3. There's not a lot extra to do there. Here we go, another one. Find the corresponding point on the unit circle for the radian measure given below, 7 pi over 4. Go ahead and look for 7 pi over 4. It's right there. So if you've got 7 pi over 4, then you've got root 2 over 2 and negative root 2 over 2. Find the corresponding point on the unit circle for the radian measure given below. If theta is pi over 3, well, we already covered this before. Pi over 3 is right there. That's going to be 1/3 of 180 degrees, obviously, because 60, 60, 60 makes 180 degrees. So we've got our 60-degree angle, 1/2 and 1/2 and root 3 over 2. We'll keep going along here. Drag each value to the correct location on the equation. Not all values will be used. Convert 210 degrees to radians. So remember, every 180 degrees is 1 pi worth of radians. So all you have to do is, we're just building a proportion in this problem. So if you have 210 degrees, what you can multiply that by is 1 pi over 180 degrees. But I don't see that as an option here. I see my 180 degrees, but I don't see 1 pi. I could do 210 degrees times something number of pi divided by 180, but there's no 1 pi option, so I can't use that. What I can use is what 2 pi is equal to, because I see 360 degrees here and 2 pi. So what I'm doing here is I'm saying 210 degrees divided by 360, and then times 2 pi will tell us how many that is. So 210 degrees times 2 pi divided by 360. So if I divide 210 and 360, that's the same as 21 over 36, which 21, 36 both divided by 3. 21 divided by 3 is 7. 36 divided by 3 is 12. So this becomes 7/12 times 2 pi. 7/12 times 2 pi would be the same as 7/6 pi, because 7 times 2 is 14. 14/12 is the same as 7/6. So that's our answer on that one. All right, number 8. The ratio of a subtended arc of a circle to the radius of a circle is known as the blank of a central angle of the circle. So first of all, let's go through these. Arc length doesn't correspond to central angles. Central angles don't have arc lengths. Arc lengths are lengths of sections of the circumference. Was known as the degree of a central angle. That doesn't make sense. There's not even grammatically, but either way, if you're not sure about these things, that's why you have the lesson tab open. It says right here, the radian measure, theta, of a central angle of a circle is defined as the ratio of the length of the arc the angle subtends, s, to the radius of the circle. So there we go. Ratio of the subtended arc of a circle to the radius of the circle. It's the radian measure. Find the corresponding point on the unit circle of the given radian of the unit circle for the radian measure given below. Again, we have 45 divided by 6. This is another one of those where we go around and around the circle multiple times. So let's go ahead and figure this out. If I've got 45 pi divided by 6, how many times do we go around the circle? Well, let's convert this to a mixed number. 45 divided by 6. 6 goes into 45 7 times with 3 left over. 7 times 6 is 42 with 3 left over. So we have 7 3/6 pi, which means we have 7.5 pi. So how many times do we go around a full circle? Well, 2 pi would make one full length of one full round of the circumference. 2 pi and 2 pi, that's 2 full. Another 2 pi, that's 3 full lengths of the circle. So that's 6 pi. So we now have 1 1/2 pi, or if you will, 3 halves pi remaining. So we have 2, 4, 6, and then another 1.5 makes our 7.5. We're going to start over after a full length, start over. So 3 halves pi is what we're looking for. So all we have to do is go back to our unit circle diagram and find 3 halves pi. And where do you have 3 halves pi on here, or 1.5 pi? Well, remember, pi over 2, 1/2 pi, is going to be your 90-degree angle. If you have 3 halves pi, you're just going to go 90, 90, 90. And there it is. 3 times pi over 2. So it's 0, -1 down there. And that's our answer. Okay, find the length of the arc intercepted on the circle by the following measure angle, following central angle. If the radian measure is 5 pi over 4, there's not a lot to it, just 5 pi over 4. There's no extra thinking here. It's just 5 times pi divided by 4. There's right there, it'd be this angle right here, 45 degrees coming off of that. So it'd be 180 and 45, 225-degree central angle. Okay, hopefully this helps you out. If you have any other specific questions or if you run into a tricky one, please let me know.